Good afternoon and welcome back to Terminal Bash. Today we are going to be looking at some code katas. We're going to be doing some code problems in Go. So, first things first, we need to decide on what kata we're going to do. I think I'm going to keep it around the 7Q range. We're going to try to be very beginner friendly. And I think what I want to do is just go through all of the katas in the 7Q range. There's not that many. And then we'll move up to 6Q, 5Q, 4Q, etc. So let's dive in. Let's decide on which ones we want to work on. If any look particularly interesting to anyone, just go ahead and let me know. All right, so consider integer numbers from 0 to n minus 1, written down along the circle in such a way that the distance between any two neighboring numbers is equal along the circumference. Note that 0 and n minus 1, which would be 9 in this case, are neighboring too. So it's cyclical in terms of the pointer. Okay. So, given n and first number divided by first number, find the number which is written in the radially opposite position. So that would be like 1 and 6, 3 and 8, I think. For n is equal to 10 and first number is equal to 2, output should be circle numbers in first number is equal to 7. So 10 and 2. Okay. So that'd be, would this be 10? 1, yeah, 10. First number, the opposite would be 7. Yeah, exactly. So, all right. Input, integer n, a positive. Are we in Go? Yeah, okay. A positive even integer constraints. 4 is less than or equal to n is less than or equal to 1,000. Input integer first number divided by first number. Constraints 0 less than or equal to first number is less than or equal to n minus 1. They're always worded so weird. But I think I could understand what's going on with that. So that is one possibility. Another would be the alphabetical addition. Task would be to add up letters into one letter. A plus B plus C is equal to F. Okay, A plus B is equal to C. Z is Z. Z and A is A. Y and C and B are equal to D. Notice the letters overflowing. I'm not sure I do. So, the function will be given a slice of letters, which are runes, each one being a letter to add. Return a rune. Letters must always be lowercase. In other words, yeah, runes must always be lowercase. The runes can overflow. See second to last example of the description. If no letters are given, the function should return Z. Okay. That one looks somewhat interesting, if not confusing. Password hashes. Simple fun. Number 152, invite more women. Alright, so task. King Arthur and his knights are having a New Year's party. Last year, Lancelot was jealous of Arthur because Arthur had a date and Lancelot did not. And they started a duel. To prevent this from happening, Arthur wants to make sure that there are at least as many women as men at this year's party. He gave you a list of integers of all the partygoers. Seems interesting, if not socially odd. Arthur needs you to return true if he needs to invite more women or false if we're all set. Okay, we'll leave that one for now. And then the other one was password hashes. When you sign up for an account somewhere, some websites do not actually store your password in their database. Some? None should. No one should ever store your password. Instead, they will transform your password into something else using a cryptographic hashing algorithm. They should all do that. If you're ever making a website, absolutely hash your passwords. Never store passwords in plain text. After the password is transformed, the password is called a password hash. Whenever you try to log in, the website will transform your password you tried to using the same hashing algorithm and simply see if the password hashes are the same. Create a function that converts a given string into an MD5 hash. Don't use MD5 for hashing passwords. It's got what's called collisions in the hashing algorithm, which means you can type two totally different passwords and end up with the same hash. Also, MD5 has what's called rainbow tables. Right? And it's a pre-computed table for reversing cryptographic hash functions, usually for cracking passwords and hashes. So basically it's like Wikipedia with the secret. Well, let's see, do we have a good example? It's a practical example of space-time trade-off using less computer processing time and more storage than a brute force attack. So we'll look at an example. Starting from hash rexes in the image below, one computes the last reduction used in the table, checks whether the password appears in the last column. Yeah. So anyway, don't use MD5. Also, there's something called salting a password. So password security salting. So a salt is a random data that is used in addition to the input of a one-way function, like MD5 is a one-way function, SHA is a one-way function. Basically, it's a prevention against rainbow tables in a way, to where if you have 1, 2, 3, 4 is equal to, like, we can do it. So for example, let's make sure we have MD5, and we can just say MD5 test, right? Well, let's man MD5. -s, print a checksum of a given string. So MD5-s test, right? So this is the MD5 of test. So MD5 A is -sa is this. Now if I run that again, that will never change, right? That is the MD5 for A. So now if I do public rainbow table MD5, okay. So here is plain text length 1 to 7. It is 27 gigabytes, right? I don't have that kind of space. Hopefully, I'm looking for like one as a web service. Okay, so enter up to 20 non-salted hashes, 1 per line. So I'm just going to do A. Tell it I'm not a robot, and just say crack hash. Unrecognized hash format. How do I specify my type? I am not a robot. Supports MD5. Yeah, so massive pre-computed lookup tables to crack password hashes. But it should work, like, maybe it just was too small. Maybe it's just not working. Rainbow table lookup online. Not surprised that no one's really hosting one. Maybe this. All right, so MD5 hash value reverse, expected 32 character long string. Anyway, they're going to be, and then it gets a little weird. So assault would be like, instead of MD5A, we'd have, you know, our salt would always go here first, and say that salt was just random string, like 5C DF1, right? So now A, which is our actual password, is having a hash that's totally different than this A hash, and thus it's, unless they have a computed table of that specific salt, they're not going to have your signature. So example usage. Here is some incomplete example of salt value storing passwords. The first table has 2 username and password combinations. The salt value is here, so the password becomes password123 and then salt, and the hash is different. A different salt value will result in a totally different hash, and this is SHA-256, which yeah, I don't think there's any problems with SHA-256 right now. Anyway, salt reuse, a fixed salt is when a programmer uses the same salt for every hashed password. While this will make current rainbow tables useless, if the salt is hard-coded into a popular product, that salt can be extracted to a new rainbow table, and the new rainbow table can be generated. Using a fixed salt also means every user who inputs the same password will have the same hash, unless password hash is also dependent on the username. This makes it much easier to attack multiple users by cracking only one hash. So there you go. So for the sake of argument here, though, we're going to be using MD5, and we're going to be hashing using that. If you want to externally test a string, look at this website, which is just going to be an MD5 hasher. We have it in the terminal, so we're fine with that. What do you guys think of this one? Do you want to do some MD5 hashing? Does that sound interesting? Let me know in chat. All right. So what's next? Okay. Drying potatoes. We'll look at a couple more and then we'll pick one. The poet and the pendulum. So first, drying potatoes. Oh, I've looked at this one before. I'm not going to read that one right now. We might go back to it. All right, so scenario. The rhythm of beautiful musical notes is drawing a pendulum. Beautiful musical notes are the numbers. Winky winky emoji. Your task. Given an array a list of integers, arrange them in a way similar to the to and fro movement of a pendulum. The smallest elements of the list must come in the center position of the array list. Higher than the smallest goes to the right. Higher. The next higher number goes to the left. Okay, that one sounds fun. So it's like 6, 6, 8, 5, 10 should be, I would guess, 10 on the right, 8, 6, 6, 5. 10. Oh, no, it's doing, oh, I'm sorry. Yeah, no. 10, 8, 6, 6, 5. So it's like, it's going to have an index and like a splicing happening, like an insertion. That one sounds kind of fun. This is interesting. So it's okay. I'm going to save that one. That one seems fun, but I'm not going to do it right now. What's one that seems... We'll start really easy. We'll just do an MD5 hash. The value should be encoded in hexadecimal. Which, yeah. So hexadecimal, for anybody, is a 16 base value system. Right? So base 16, which basically means 0 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's those values. And then 10 would be A, 11 B, 12 C, 13 D, 14 E, 15 F. So 0, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Base 16. Right, so if we were in, we'll just jump in Python real quick, and I think it's 0, or how is hexadecimal? XA? Let's do Python 3 hexadecimal. Zero X A 10. Yeah, there we go. So 0x is the prefix for hexadecimal in Python. So 0A0 is 0. 0A01, right? So how do I explain how that works? So A is 10, AA is 170, which is interesting. 0, 0 is 0, 0, 1 is 1, 2 is 2, A is 10, 0, 0, A is 10, but 1, 1 is 17. And I'm not sure how to explain that one, unfortunately. But anyway, you get the idea. So 0x F is 15, which makes it base 16 because 0x0 is 0, which that's why it's off by 1. Okay, so now that that's out of the way, let's get back to this hash. So let's go ahead and train this. So we're going to have our tests. We're going to make a directory. I'm going to call it password hashes. And I'm going to say MD5. We'll cd into that directory, and we'll touch kata test.go and kata.go. And we'll vim the test first, of course. And then I like to use just the default testing, and I keep the same package as in my main.kata. So in main, oop, I didn't mean main, I meant in my kata.go. So what we'll see here is a package called main, and then because I know, well, we'll see if I don't need to use funct, right? So we need a variable for our hash tests, and that's going to be a slice of structs. Is it struct slice or slice of struct? I don't even remember anymore. I think it's a slice. Yeah. Yep. Okay, slice of struct. Which is going to have an in. So if we take this function and just go ahead and paste it on in here. So we've got function pass hash. And it's going to return a string. So I'm just going to return an empty string for now. And we bring in a string. So our in is a string. And our out is a string. Which means inside of here, we have in, out, and we do that, 3 times. And our in is just going to be this example test case. And then for register Z, delete inside of quotes. So then we can go to 12, and we will paste, and then from register Z we'll paste. Oh, I should have done, so for register Z, we take that, and then for register X, we take this. So on line 12, from register Z, we can paste this, and from register X, we can paste this. That's just a Vim nicety. Delete inside of here. This should actually be here. Okay. And then we expect it to equal, so register Z, register X, and register C. And then we just do it again. Register Z paste, register X paste, and register C paste. So that's our different values for the different string in to the string, or the hash out, which is a hexadecimal string. And then we're gonna need a func, and we're gonna call this, this is going to be test hashes, and it's gonna take in t from testing dot t, and then for test in the range of our hash tests. That's where we're going to get our result, and that's going to be equal to pass hash. So pass hash, and then test.in goes in, and then we say if result does not equal test.out, then we're going to say, hey, we've got an error that we need formatted from test in, so that's like string, expected our test got the result. So test.in expected test.out got result. Okay. And then simply, so first things first, this password hashing, go run kata dot go, maybe. How did cannot run non-main package. I forget how I do this. Go. Should just be go run. Go run, compile and run a Go program. Go test. Go test. Kata. No test files. Kata test.go. I'm sure it is a test file. For sure there is. Go test. Oh, I need to create my module. So go mod init terminal bash / password hash md5. So now that that's done, we can test. Okay, so we see that from should test that the solution returns a correct value, expected this, got an empty string. Okay, so that's good to go. So now we're just going to look up Golang MD5. Okay, so this is going to be from the crypto MD5 package. So import crypto MD5, and then inside of here it looks like we just got a new function, and then so the sum, let's see, new returns a hash computing the MD5 checksum. Do we have an example? H is new, write string H, and then we put the string in, and then we sum H. So we have to create a new one, and then we can use IO to write string, or in reality, all it requires is a slice of bytes in, and it gives us a slice of the size back in byte. So let's say our hasher is going to be equal to md5.new, right? Which matches here. So we've got the new hasher, and we can just say, so from Golang string to slice to byte array. I'll go with this. How to assign string to bytes array. So it's just a slice of bytes and pass in the string. So we don't need this IO write string. We can just do it ourselves. So we are going to say just a return of, so a couple of things. Can we cast a slice of byte? So go playground. I have to use the go playground because there is no read, evaluate, print loop in Go. So the playground is like the best thing I know to find. But we want to print, so we've got our string, which is equal to hello play. Or we'll just say hello. Okay, we've got our string, and now we want to thump print. Actually, we want this to be a slice of bytes, right? Does it do that, or can I initialize it? Yep, that looks like how it wants it. Slice of bytes, and then we're just going to print our string, which is not a string. So we'll call it our data. Our data is fine. And we'll run it, and we can see we get a slice of bytes, right? So 72, 101, and so for example, if I were just to thumped print line a rune of H, I would expect those two to be the same. So 72, 72, which means this is a rune. A slice of bytes is a slice of runes. So then we want to get this slice of bytes to a string. So I'm just going to see if I can just cast the slice of bytes or if I need string convert. And I can just cast, you know, wrap string around our data, and it marshals it into a string from the slice of bytes. So we'll do that. Okay, so we return hasher dot sum of string slice of bytes of string, and then we just take that into a string. So we create a hasher. Is there any way we can get away with not having to create that and just sum? Unfortunately, sum looks to be... Okay, no, I can do it. I can just say MD5 sum the data. So I can get rid of this. I can change this to MD5 sum slice of bytes string, cast it into a string, and return it. And that should be all we need to get this to pass. Fail. Cannot convert MD5 sum byte slice of string type 16 byte to string. Okay, let's try that. So it's saying if we have 16, a 16 byte. So Golang byte slice. So slice of size. Okay. Inside of here, we'll say slice of byte 16, and then we'll test this. We'll just say, there you go. Print our data. What do we get? Right. So we get a slice that's 16 long, and I could say H E, you know, and that'll populate into this allocated area. What if I pass a string HE? It does not like that, right? So I will need to initialize this with that. And then if I try to string this, do we get an error? Right. So perfect. So let's do this. Type 16 byte to string. Size byte to string. String of the byte from end to end, referring to it as a slice. So in that thread of logic, that would mean our data slice works. And there we go. So that's all we have to do. So slice of bytes string, we know that this sum basically to here needs to be referred to as a slice. Slice of an unaddressable value. So let's do this. Result is equal to MD5 sum of the slice of byte for string and then result what's the malfunction? Ah, there we go. Okay, and now we test it, and there. So we're failing. We say got 7q1t star equals from the length of the hash string must be 32. From the length of hash string. Oh. From should handle empty string. Expected this, got, and we're getting very little back from our hasher. So, and then we just fail. So let's look and see what we've got. So I'm going to bring in fumped. Womp, womp, womp. Tried to avoid it. And we just want to fumped print line result. So we're getting this hash, and if we print it out as a slice, we get the same thing. And if we convert that into a string, we get very little. Why? So let's figure out. So we've got our sum of the data, and let's just see what happens when we print it like this with the formatting. I think this X is the hexadecimal. We'll verify, but it's basically sum of result. Well, result's already a sum, so it's just result. And that's what we expect to see, right? So print ln, can I maintain my formatting like that? ln f. Okay. Print line, okay. Print formatted, and just give me a new line. There. So that's our actual hash. So I guess the question is, can we do slice of byte of hex to string in Go? So encoding hex, we can decode or encode. So what happens when we decode? So DST, decode decodes source into decoded length of source bytes, returning the actual number of bytes. I'm not sure we want that. How to get Go from bytes to get hexadecimal. They're using IO writer, and then they're printing F. Return base 16 with lowercase letters for A through F. Return sum of nil. So that's the question. And the answer is, if I understood it correctly, you want to return the %x format. We do. You can import hex and use the encode to string method. So that looks like what we'll have to do. So inside of Golang hex, encode to string. All right, so let's do that. So instead of casting to string, first off, on line 5, we'll change this to hex, and then we'll get rid of these. And then we can change this to encode. So it's hex.encode to string. And then maybe at this point we could just pass it this guy. So just hex, encoding hex. Encoding hex. Okay, so we still have to maybe slice it. Okay, got different hashes. I think I got my hashes mixed up. Right, expected E99. Well, doesn't look like it. From should handle empty string. So if we look at this and we just take everything inside of here and over here we just MD5 this string, we expect 37 E2, and that's not what we expect here. So if we go back to the kata, maybe the kata is being a little more odd than we expected. So what is password? MD5-S -S password 5F4DC 5F4DC. So why was it saying? Oh, I got this wrong. So it's expect password ABC123 and empty. Password ABC123 and then nothing. Okay, and now we're passing. So that's as simple as this one is. You will notice, so like, oops, a really long sentence can also have an MD5 hash even with punctuation, something like that. And if I take all of this and I run it through my MD5 check, MD5-S, and I can see that a really long sentence has a hash of A658. The hash is much less long. The length of the hash is less than that of the sentence. And that's just how a hashing function works, right? You can pass in MD5-S A, and it's the same length as AB, or, sorry, AB. And the only reason it looks longer is because I've got extra space there. These lengths are the same. And this works for any length of string. That's what a hasher does. And that's why they can't be reversed as well. So what I could do is I could take this hash that we see here and I can go forward here and just paste that in there and save it and run the tests and watch it pass. Okay, so we're good on this. I'm just going to, I wonder if I could wrap this and then reference that. And then result could just be this. I'd love this to be one line. It doesn't like it. Unaddressable value. So not sure how to get around that personally. I'm just gonna leave result there and see what we get. So in here, we'll just paste in this code, run our sample tests, pass all of them, and then attempt and pass all of those. Okay. We submit the final, and then we get to look and see what other people have done. So, same thing, right? Some byte slice of the string. This is me. Same thing. They did a sprintf versus hex encode to string. I'm not sure which one is more performant. I'd guess encode to string would be, but again, I'm not sure. They're using IO to write the string unnecessary, because you can just do this byte slice of string. Byte slice of string, and again, crypto and encoding only. They are writing to the hash. They're doing this and writing to it unnecessary. because you can just sum and pass in, instead of nil, you pass in the slice of bytes of the string. Here we go. Here's a nice one-liner. So they were able to MD5. Oh, so I don't have to. Really? I thought I did. Interesting. But if I funct.sprintf %x result, and then funct, that does work. So they're just trading one solution for another, and it allows them to have a one-liner, but I'm guessing it's less efficient. I'd rather have two efficient lines than one inefficient line. Sprintf. Is there anyone that got one line without sprintf? No. Okay. So there you have it. How satisfied are you with this kata? I'm somewhat satisfied. It's fine. Don't you guys agree? See if we have general agreements from the chat. So I've been streaming for 50 minutes, and I don't think I have anyone that's joined, which is a shame. Nope, there are people. Okay, good. As long as it's not for nothing, you know. Okay, so that was password hashes. That one was easy. We're not going to do this one. I want to do this one. Simple fun, number 2, circle of numbers. So we can close out of this. CD up directory. We're going to make a directory called circle of numbers. Circle of numbers. And CD to circle of numbers. So we are going to touch kata.go and kata test.go. We'll go mod init terminal bash / circle of numbers. Okay, and then go test will complain. So vim kata and package kata import. Actually, let's go ahead and train on this kata. We're going to take in the tests. Anybody who's watched before knows that I like to just use testing rather than all of this other imports that they recommend. So first I need number circle tests, and that's going to be equal to a slice of struct. Okay. And this struct is, let's look at what it's going to be. So in kata, I'm going to have 2 arguments coming in here, and I'm going to be returning an int, right? So I need up here a type of inputs, and it's going to be a struct, right? So basically what this means is I've got 2 arguments. So we'll say arg1, and that's going to be integer here, and then arg2 is also going to be an integer. So int, and then we'll just replace that with 2, and then on the input we're going to have inputs, and on the out we're going to have an int. right? So we can initialize this. And I'll zoom in for y'all. So on the input, we need inputs that's initialized. And we'll just go ahead, for the sake of readability, tab these over appropriately. And on the output, we need an integer, right? So we can know that we're expecting 7 here. Okay. And then on the input, we expect 2 and 10. So I'm gonna for register Z, I'm gonna take those for register X. I'm gonna take these for register C. I'm gonna take these for register V. I'm gonna take these, and for register B, I'm gonna take these. Okay. And basically, we can put this on one line, and then I think I want to just paste register Z, and that'll just be argument 1 and argument 2. And then I'm just going to do this 4 more times. So we've got those. And then basically, we can register XP. Register CP. Register VP. Register BP. And that's all of our registers. And then I don't need this last one. Wait, did I? What do I have going on here? What's wrong? That should be this one. Oh, I didn't end this correctly. Okay, so then on line 36, we can remove that. Okay. If you like what you're watching, go ahead and throw a follow my way. I try to stream at least 2 nights a week. Looking to stream more over time. And you can also follow me on Twitter at Terminal Bash. All right. So we have the inputs. Now we need the outputs, right? So replace for 2, replace for 3, replace for 0, and then replace for 10. All right. And then we can get rid of this. So we're going to test our circle. And then we're going to bring in T from testing. And for the tests in my circle tests, the function is called circle of numbers. So result is going to be equal to circle of numbers, and we're going to pass in, and this is the interesting part. So this is the struct that we built. So it's test.in.arg1 and then test.in.arg2. And then we know that that will return an integer. So if result is not equal to test.out, which is going to be like an integer, we are going to t error format, and what formatting we want is going to be from percent plus v got expected percent d for digit got percent d for digit, And then in the end, it's going to be test.in got test dot, or expected test.out got result. Okay, and that's it for our tests. So right now, everything should return 0, which should be a problem for our tests. Okay, so from 10 to got expected 7 got 0. From 10 to expected 2 got 0. Or I'm sorry, 10, 7. Yeah. Okay, so now if we look at this, so basically what the complement is it complement? Consider integers, distance between two, given in, and first number over first number. Oh, first number or first underscore number. Find the number which is written in the radial opposite. Right, so do we even need to make a circle? Let's see. Let's look at this. So 10, the opposite in 10 of 2. So let's open up some Paint browser. Ugh. It's actually Paint. That was literally Paint. Sumo Paint. It's probably going to be this one with this weird little name. It's probably going to be like the super clean interface. Yeah. Overly killed. Icky. It's okay, but this is what we want, right? So we've got a circle. Wow, I wish I had a touchscreen right about now. How do we undo? So got a circle, and the first is 10, or there's 10 numbers, the first is 2. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oops. 10, 11. Right? So 2 is 7. Right? The opposite of 2. Which would be... So, think about another circle. Down here. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. The complement of 8 is 2. Complement of 0 is 5. So if we think about this in terms of an array of 0, 1. This is hard with a mouse, I'm telling you. 2, 3, 4, 5, 6, 7, 8, 9. right? It's 10 numbers in total. So we know that the opposite of 2 is 7, or 0 is 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it is the length, let me fix that, length of the array divided by 2 plus, fix that, plus 1 for even arrays, right? Okay, so let's go ahead and we'll create a new sheet here. So what about an uneven one, right? So 1, 2, 3. Can we even, do they even have uneven in our kata here? N to n, or 0 to n minus 1 written down along a circle in such a way that the distance between two neighboring numbers is equal. Find the number which is written in the radial opposite to the first number. So in the code that they gave us, let me just make sure. Is chat working? You can throw a chat in if you're lurking. Just let me know if it's working. Okay, so for the tests that they gave us, 10, 10, 4, 6, 20, but they never give us an odd number. So like, what do we do if it's odd? Right, because it would be 1, 2, 3. What's opposite when they're equal distances? Do you get 2 numbers back? We only return 1 from it. Do you round down? These are questions that are going to need to be answered that are probably in the longer one. So constraints. Oh, a positive even integer is input, so it has to be even. So yeah, so it's just okay. So let's think about it like this. And I'm just going to use this as an example down here. So we're going to create a comment, and we're just going to say we've got a list of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? That's even, and that's going to be 5, right? In a circle, that would be 5. So by that merit, if we were to do 10, then it would be 6. Right? And it's always going to be like that. So in one that's even, so if the length is 2, then 1, 2, the opposite is going to be 2. If it is 4, one, 2, 3, 4, right? It's going to be, the opposite is going to be half plus 1. So if the length of n is equal to 2, then return n plus 1, right? Otherwise, we're going to say return Okay, wait, hang on. We need first number plus 1. Otherwise, we're going to say return the first number plus if it's 10, we would just do n divided by 2. Invalid argument for length. Oh, I guess it's not length. It's just if n is equal to 2. Expected to got 12. For 10, 2, or 10, 7. So it would be 7 as the first. Expected 2. Hang on. Maybe I misunderstood something here. So 10 is the int. Oh, 2. 10, 2. No, 10, 7. What is that one? To equal 2. That can't be right. For n is equal to 10 and first number is equal to 2, it's equal to 7. Is it only 10 numbers? This doesn't make sense. Oh. Okay. Okay. So maybe I should do this by building it out. So it'll have to wrap when the number... Okay, let's do this. So we know the total length, right? So var, or we'll say our list is equal to a slice of n slice of n slice int. Okay, so it's that big, and then for I is equal to first number. I don't think we even have to do that. We could just say, now we'll do that. We'll track I. I is equal to first number. I is less than n I plus plus, and then if we want the length of list. If the length of list is less than n, okay, if I is greater than, we'll start there, greater than what time is it? Brain is shutting down. If it's greater than n, we need to wrap it around. So we'll say I is equal to 0, and we can just reassign. Otherwise, we just continue on and we push to the list. So list is equal to append of list I. Push that into the list. Okay, if then we return list 1. Otherwise, we've got this list, and we need to do, half. So list in divided by 2. Now, let's see how broken that is. Array non-constant array bound in on 410. Non-constant. How is that not constant? In never gets changed. What if we just did 10? First argument to append a slice, or must be slice. Oh, a slice of int. And it says have 10 int. Append. Okay, we'll just do a list. Okay. Expected 0 got 6. Expected 2 got 1. So 10, 7 should be 2, got 1. 6, 3. So what we need to do is we need to funct. We just need to debug this real quick. So what does %v look like for a list? Why are you so angry? Partial for print f. So, okay, this makes sense, right? It should be 0, 1, 9. It shouldn't be 10. Less than or equal to. There we go. 9. Well, no, shouldn't be 10. N minus 1. 2, 3. No. No. So this is very simple. 2, 3, 4, 5, 6, 7, 8, 9, and it should never reach the length of list minus 1. What was the difference there? 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 5, 6, 7, 8, 9, 10, 11. Which makes no sense. The length of list. Oh. Length of list is less than n 10. Less than or equal to. I thought that was right, but it's not. in minus 1. Why are you doing this to me? What am I missing? So, first number is 2. If in minus 1. Okay. What happens if I tweak this stuff? Bad news. And if I tweak this, bad news. But if I get rid of this, good news. Okay, I want to keep it like that. Oh, and I passed. Cool. Let's just try this real quick. All right. Sample tests. I expect these to pass, and I was wrong. Imported and not used. Yeah. That's fair. I expect these to pass. Good. Okay. So now we attempt. Bingo. All right. Is there anything we can do that's better than this? Anything at all? I like my declaration like this. I could also create a var and not initialize it. And technically, it saves a character. But I just like this for some reason. I can't explain it. I cannot explain it. And that's fine. So, list is equal to append list I. Just populating it. If n is 2, return 1. Otherwise, n divided by 2. If I took n being 2 divided by 2, I'd get 1. So that works. We'll just attempt. So that saves some code. And then I really want this to be different. So I want we don't really have ternaries. Like if this, then like I is equal to 0. But I don't think we have that. One line. Let's do Golang one line if. Doesn't really. How do I do a one-liner if else? I don't want that. Right, so they say if. Yeah, so I don't think I can. So I'm just going to go ahead and submit final. Let's see if anybody beat it. There it is. Modulo. Well, it's a modulo, huh? That's really good. First number plus n divided by 2 modulo n. And then they don't have to create any of that crap. Right. So that'd be like 2 plus 10 divided by 2 modulo n. Cool. That makes a lot more sense. All right, so that's the best. So this to me is best practice. I don't know why I didn't think about using modulo. So like let's experiment with that in Python. Right? So we've got 10, or we'll say the first number is 2 plus 10 divided by 2. So that's 2 plus 10 divided by 2 is 6. Modulo 10 is 6. Yeah, so basically what's remaining, what's under 10? Well, 6 is under 10. Do we need to do modulo? We do, because like 20 divided by 2 modulo, do we need to? Modulo 20 is 11. So could we just do first number plus n divided by 2. Modulo n. Wait. First number plus n. N divided by 2. Okay, so back into Python. So it's 2 plus 10 over 2 is 7. Modulo 10 would be 7. So in this case, it would have been, for the instance where, okay, so this is where modulo comes in. So for the instance where first number is greater than the second number, which is n, which in our case will be 7. No, n. First number is 7 plus 10 over 2 is 12. So in the case where it's over, the total is over the pass in, then we get 2. So modulo is exactly what we need. Cool. Modulo n. I like it. All right. I think that's where I'm going to call it for tonight. So in an instance where you're dealing with bounds that wrap around, modulo is going to be key, which makes total sense. Should have thought about it first. This is not nearly as effective because I'm having to do an O of n operation, whereas this is just like some simple math. It's almost like O of 1. You know, kind of computation. Although I'm not sure the implications of modulo and big O. I might look that up at another time. So that's it from me for now. Thanks for tuning in. Check out the next stream. Look for these uploads on YouTube and check me out at terminal. I believe it's, let me verify, terminal terminal_bash on Twitter. Nope, yeah, at terminal_bash. And then go ahead and hit a follow on Twitch, subscribe on YouTube, and I'll see you next time. Thanks.